So lesson 2.5 is completing the square. So completing the square is a method that is used to find what we call vertex form of a quadratic. Okay. Vertex form, we've talked about vertex form in the past, but vertex form is basically a format of your quadratic that allows us to see what the vertex is by just looking at it. So we can go from standard to vertex form using completing the square. And it also is helpful in finding solutions as well. So this is just a little bit of a visual graphic to what completing the square does. Okay? If we have a quadratic that doesn't have a c term, we take half of the b term, okay, and then we square that, and that becomes our new c term. So the first thing we're going to do is we're going to practice solving square root solutions before we get started to refresh our memory, because that helps us in completing the square. So go ahead and look at example number 1. Alright, so for example number 1, when you use square root solutions, you use square root solutions when you don't have a b term. So as you guys can see, we have an x squared term and we have constants, but we don't have a b term. Everybody see what I mean by missing the bx term? So what we're going to do is we're going to get this x squared by itself. So what's my first step in doing that? Good. Subtract 50 from both sides. That leaves me with 4x squared is equal to negative 4. What's my next step? Good. We're going to divide by 4. And when we do that, we get x squared is equal to negative 1. Now, in Friday's lesson, we learned about how to take the square root of a negative, which is going to be important here. So, how do I get rid of a second power in math?
Square root.
Good. We take the square root of both sides, which leaves me with x equals. Remember, when you take the square root, you have to do plus or minus. Now, what is the square root of I squared?
I.
Yeah, did I say I squared? What is the square root of negative 1? I. I don't know why I said I squared. So your two solutions are x equals I and x equals negative I. You guys remember that from the last lesson?
Wait, where did I come from?
You remember how in the last lesson we talked about imaginary numbers? And the square root of a negative 1 is I?
Oh, okay, so you're still, okay, I wasn't sure if like that was still a thing in this lesson.
Yeah, that's why. So you know how it was weird how we went from quadratics and then we took a break and did all the imaginary stuff and then we're doing quadratics again?
Yeah.
That's because now this is like there's times when your quadratic solutions are going to have imaginary solutions. So we had to stop in the middle of the quadratics and talk about imaginary numbers because they're going to come up in solutions throughout quadratics. Okay, so yeah, the i's aren't going anywhere. Just to quickly refresh on that in case you've forgotten, the square root of negative 1 is I. We talked about in the last lesson. Anytime you take the square root of a negative number, it's always going to be whatever that square root is times I. So those are your two solutions. Does anybody have any questions? All right, let's try the next one. So what's my first step to get x squared by itself? Good. So we're going to add 5 to both sides. That gives me 3x squared is equal to 30. Then what do I do? Good. Divide by 3, which gives me x squared is equal to 10. What do I do to both sides? That leaves me with x equals plus or minus the square root of 10. Now, the square root of 10 cannot be reduced. Okay, you can't simplify it or break it down in any way. So, when that happens, you're just going to leave your answer as a square root. So you're going to have x equals square root of 10 and x equals the negative square root of 10. And if you plug either of those solutions into your equation, you'll see that you will get a true statement. So any questions so far on how to solve square root solutions? the main important thing that people often forget is when you take the square root of both sides, you need to have a plus or minus for your solution, because there's two ways you can get a positive or negative with a square root. You can get a positive or a negative because of the properties of square roots. Okay. So now we're going to talk about perfect square trinomials, okay? And this is going to involve you to use your skills from the last lesson, or the lesson before that, to factor on the right. So let's pretend for a second that the right side doesn't exist and we're going to factor on the left. How would I factor this? You guys remember? We can't find a GCF because they don't have a GCF because of this term. There's no 4. But you guys remember we look for factors of 4 that multiply.
Why wouldn't you subtract 25
So you could do that to factor. That would be the normal way to do it. But we're trying to do perfect square trinomial solutions, so I'm showing you an alternative way to do it. Yes, you're right. You could do it that way too, and I will show that.
Why do you cross out 25? I'm sorry.
Oh, it's just because I didn't want you to think about it right now because we're just trying to factor the left side. So I was just like, don't think about the 25, just think about the left side for a second.
Okay.
Okay? So we're looking for factors of 4 that add up to 4. So that would be 2 and 2, right? Everybody with me on how I did that? Now, when I crossed out the 25, that was just for you to not look at it for a second. So the goal was to just factor the left side. So we factored it, and we get 2 identical binomials. Anybody know how we can rewrite 2 identical binomials?
Wouldn't it be x plus 2 squared?
Good. X plus 2 squared is equal to 25. Now, in math, how do we typically get rid of a second power?
Square root.
Good. We take the square root, and what we do to one side, we have to do to the
Other.
Good. So that's going to leave me with x plus 2 is equal to plus or minus 5, right? Now, in math, whenever you get that plus or minus, that basically means you're going to have 2 equations, okay? You're going to have one equation where you have the regular 5, and you're going to have another equation where you have the negative 5. And now we're just going to solve each of those equations for x. So I subtract 2 on both sides. That gives me x equals 3. And over here I subtract 2 on both sides, which gives me x equals negative 7. And those would be my 2 solutions. So you were right. You can find solutions using another method as well. You said to subtract the 25 on both sides. So I am just going to quickly show you that another way you could have done this, which isn't what we're trying to talk about right now, but you could have subtracted the 25 from both sides, and you get x squared plus 4x, what is that, minus 21 equals 0. And then you could have found factors of 21, negative 21, that add up to 4, which would have been, yep, so positive 7 and negative 3. And then you would set each of those equal to 0, and you would have got the same answers.
Oh, is that why you're doing factors? Okay, from that one lesson we learned?
Yes, yes.
Okay.
You remember now? It's like, this lesson's difficult in a sense, not difficult, but there's a lot of different pieces from different lessons. And because we're on block schedule this year, it's hard because you have everything so spaced out. So sometimes it's hard to remember everything. I know.
What lesson is that from again?
That would have been from lesson 2-3, I believe. 2-2 and 2-3 maybe. Does anybody have any questions about this part? All right, we're going to try this one. So since we have some time in this lesson, because we're only doing one of them, I'd like you all to take a second to try doing this problem by factoring the left side first and then doing the square root method, which I did on the first problem. Okay, the first thing I did, you factor this side pretending the 9's not there. Okay, go ahead and try that, and I'll walk around to help you guys out. So go ahead and give that a try. I'm going to pause the video. So for this problem, we're going to factor the left side first, kind of ignoring the 9 in the beginning. So my goal is to look for factors of 36 that add up to 12. And what'd you guys get?
6 and 6.
Good, 6 and 6. Because the product of 6 times 6 is 12, and the sum of 6 and 6, the product of 6 and 6 is 36, the sum of 6 and 6 is 12. So then how can I rewrite two identical binomials? Good, x plus 6 squared equals 9. And then what can I do to both sides? Good. And this becomes x plus 6, and over here what do you get? Plus or minus 3. That means we have two separate equations here. We have the equation that has the positive 3, and we have the equation that has the negative 3. So then from here I'm going to subtract 6 on both sides. This gives me x equals negative 3. And over here I'm going to subtract 6 on both sides, which gives me x equals negative 9. So my two solutions are x equals negative 3 and x equals negative 9. Any questions on that? Okay, so from here we're going to start talking about completing the square, which is the main idea of this lesson. We haven't done it yet. So I want to talk a little bit about what completing the square is. So completing the square is basically a method to factor trinomials that don't want to factor. Okay? So basically you have a C term, like always. Okay? And that C term, you find the factors of that C term and they don't add up to any of the B terms. You can't get anything to work. So this is when you use completing the square. Okay? Completing the square basically forces trinomials to factor that don't want to factor the way we have been learning. So what we do is we basically come up with our own C term that's going to make it factor. So we're going to practice how to come up with that C term before we get started on actually doing it. So the method you use to come up with that C term is you take whatever that B term is, in this case 10, you divide that B term by 2, and then you put it to the second power. Okay? And that's the method that you use to find the new C term. So let's try it with our actual B term. So negative 10 divided by 2 squared. What is negative 10 divided by 2? Good, negative 5. And what is negative 5 to the second power?
25.
Good, 25. That's how you come up with your new C term. And now, what would happen here is this would factor now, right? This would factor into x minus 5 and x minus 5. Okay? So, what? Oh, I just said that. So, what we did was we came up with our own C term. Did you see how I did that? Now, what I'm saying is, what this allows us now is if I wanted to factor this trinomial, it would factor into x minus 5 and x minus 5. X minus 5 times x minus 5. Because factors of 25 that add up to negative 10 are negative 5 and negative 5. So the reason I'm saying that now is because you're going to have to factor these. And you don't have to do the work twice. So that factor that's going to be your factor in your binomial is always going to be whatever half of that B term was. Alright? So this would factor now into x minus 5 and x minus 5. So let's try the next one. So we take half of our C term. What's half of 6? And then you put it to the second power, which becomes 9. And your two binomials are always going to be whatever half of that C term was. What was half of that C term again? I'm B term, my bad. Yeah. Good. So it's a tool to allow us to factor it. Yes?
So when you're doing that, do you stop after writing the x plus 3x plus 3, or do you keep going?
In reality, you're going to use it to find a solution. This is just like a piece of that in this part of the lesson, if that makes sense. So normally no, but right now yes. Now for this one, everybody's favorite, fractions. What is half of 1/2? 1/4. Good. And what is 1/4 to the second power?
1/8.
Not 1/8. So we take 1/4.
Oh, I think 1/6.
Yes. And we put it to the second power. You square the numerator and denominator separately. 1 to the first power is 1. And 4 to the second power is 16. So you would get 1/16. Now, to factor it into two binomials, this is where that step where you had to divide it by 2, you don't have to do the work again. You're not going to try to find factors of 1/16 that add up to 1/2. That's hard work. So we know that it's always going to factor into x, and then whatever half of your b term was. What's half of 1/2 again? 1/4. That's how it's going to factor. That makes sense so far? Okay. So let's try actually completing the square on a few of these. So, example 4. So how do you complete the square? Well, the first thing you always want to do to complete the square is you're going to want to get rid of this c term, okay, because we're going to make up our own c term. So how can I get this c term out of my way on the left side of the equation? Yeah, I can subtract it to the other side. So you're always going to get your c term out of the way by bringing it to the other side, whether that be addition or subtraction, according to whatever sign you have. And then what you're going to do when you subtract it over, instead of usually how you would write it right here, you're going to leave a space. Okay, you see how I leave a space right there? You're going to leave a space because that's where your c term that you're going to create is going to go. Now, from this step, you want to confirm that your a value is 1. Now, in this case, is my a value 1? No. So you're going to have to do some work before we can move on to the next step because your a value is going to need to be 1. Now, think about the left side of my equation. What can I factor out of that?
4.
Good, I can factor out a 4. So this is going to become 4x squared minus 2x. And now what you're going to do is you're going to end your parentheses over here because you have to put in that c term that we haven't created yet. Now we're going to create our new c term. So we take half of our b term. What's half of -2? -1. And what's -1 to the second power? That's what I'm going to add here. Now, we have to think about this for a second. Whatever I add to one side of the equation, to keep the equation balanced, I need to also add it to the other. However, did I actually add a 1 to this side of the equation? Or what did I actually add to this side of the equation? The 1 is being multiplied by 4. So technically, if I were to have distributed the 4 back out, I actually added a what on this side? A 4. So in order to balance my equation out, I need to add a 4 to the other side. So you always distribute this, and whatever that is what you're going to add to both sides. It's kind of weird, but it works.
So then would you distribute that, or would you just add the 4 to the -3?
We're going to add the 4 to the -3. We're not going to distribute for the fact that it's not going to help us. We need to factor it back out. But that's just a tool to help you figure out what's going to be added to the right.
Okay.
Okay? Now from here, now that we figured out what we needed to add to the right to keep our equation in balance, we can now factor what's inside the parentheses. Now remember how earlier when you want to factor this, it's always going to factor into whatever half of this term is. So what is it going to factor into? Good. X plus 1, not x plus 1, x minus 1 and x minus 1. And if you think about it, if you want to rationalize this, we're looking for factors of positive 1 that add up to negative 2. That's going to be negative 1 times negative 1, which multiplies to give me positive 1, but adds up to a negative 2. So now from here, I just simplified what I have on my right by adding these two numbers together. And now how can I rewrite two identical binomials?
X minus 1.
Good. So this is what we call the critical point in our solution, okay? And this point is really important because when you get to this point, this is where you determine if you want to find solutions or you want to find the vertex form. Now, this question asks you for which one? It asks us for solutions and vertex form, doesn't it? So we're going to have to find both, okay? So I'm going to show you how to do both from this step. So you always go from this step to find both. So from here, let's say we're going to do vertex this way. So let's say this way we're going to do the vertex. So the vertex form is actually very easy. All you have to do is get the 1 to the other side. So how can I get this 1 to the other side? Subtract it. So it's going to be 4 times x minus 1 squared minus 1 equals y. And that's your vertex form. So all you have to do is subtract or add that one number over. And then you have vertex form.
How come you put the y on the other side?
It doesn't matter. When you have two things equal to each other, basically that just means that it's like x equals 4 or 4 equals x, same thing. The symmetry property. So from here, we're going to go ahead and find solutions over here. That one's going to take a few more steps. So when I go to find solutions, I'm going to rewrite my equation. And then your goal when you find solutions is to get the squared binomial by itself. So how can I get rid of this 4 over here? Divide. That's going to give me x minus 1 squared is equal to 1/4. And then how can I get rid of a second power? Square root it. That's going to give me x minus 1 is equal to plus or minus 1/2, because I square root the numerator and square root the denominator, and that's how I got 1/2. Now to find my two solutions, I have a positive and negative version. I have x minus 1 equals 1/2, and down here I have x minus 1 equals negative 1/2. And you're going to solve each of these for x. So for the first one, I'm going to add 1 to both sides, and that's going to give me x equals 1 1/2, which is also 3/2 or 1.5. And then over here, I'm going to add 1 to both sides, and that's going to give me x equals 1/2. So my two solutions are x equals 1/2 and x equals 1 1/2. Does that make sense so far? All right. I do want to show you something before we move on, because to me, I think it's important that you understand why things work and how there's multiple ways to do things sometimes. And that's because if you get to a test and you only remember one thing, I want you to try to be able to use whatever tools you have. So does everybody have what I have down? Does anybody need a second? All right. So what I'm going to show you now is I'm going to show you something and how this relates to other things we've learned. Because I think for me, when I learned this, it helped me better understand what completing the square was. So we found our solutions completing the square, right? Let's go back to last week for a second and think of how we learned how to solve for solutions for this quadratic before we learned completing the square. So remember how we always checked and saw, is it in the form ax squared plus bx plus c? Yes. Is my a term 1 here? No. How do we adjust when an a term is not 1?
Add the 4 to the c.
Yeah, we multiply the 4 and the c, and we would get x squared minus 8x plus 12, right? And then we would look for factors of 12 that add up to negative 8, which are 6 and 2, negative 6 and negative 2, right? And then how do we adjust that? We divide both of them by what? The 4. If they divide, we divide it. If they don't, we reduce it. This would become x minus 3/2, and this would become x minus 1/2, right? Well, aren't those the two solutions we just got if you were to solve these out? 3 over 2 is 1.5. So this is another way you could have got your solutions, right? Now you wouldn't have gotten vertex form, but you would have gotten your solutions that way. So there's multiple ways to do the same thing. Another thing I want to show you is, what did we learn about the vertex back probably a week ago? We learned that we can find the vertex by finding the axis of symmetry. How are the axis of symmetry and vertex related? Yeah, the
Yeah, the
axis of
same Y
symmetry,
value.
yeah, the axis of symmetry is your h, right? The x value of your vertex, because it goes right through it. So, could I find the x coordinate of my vertex using that formula for this equation? Using negative b over 2a. Remember that formula? So this would become x equals 8, because a positive b over 2a, which becomes x equals 1, right? So the x coordinate of my vertex is 1. How could I find the y coordinate of my vertex using that x coordinate?
Plug it back into the equation.
Plug it back into the equation. That gives me 4 minus 8 plus 3. That gives me negative 4 plus 3, which is negative 1. So this is h and this is k, right? And then what is my a value according to the equation? 4. Those are the 3 pieces of information you need to find vertex form. A times x minus h squared plus k. Well, that's just going to be 4 times x minus 1 squared minus 1. Isn't that what we got completing the square? Yeah. So, I'm not saying to do this, but I'm just telling you that if you get stuck, you can always check your work doing this. Okay? I just want to make sure you're aware of this, that it's the same thing. So, any questions about that? You're starting to see the connection between the two now that I showed you?
So if you need help finding,
If you want to check if you've completed the square correctly, you can do this. Okay? Alright. Now, like I said, this is a fail-safe. It's not a method, because the problem is there's a lot of questions where they're going to give you the steps of the completing the square and say, where did this person go wrong, or something like that. So you need to know how to complete the square. However, this is a good way to check and see if you've done it correctly, if you want to know if you've done it correctly. So let's try one that's going to come with fractions. Alright, so let's complete the square. So the first thing we're going to do is we need to get our c term to the other side. So we're going to make a new c term. So I'm going to subtract the 8 over. That's going to give me 3x squared plus 10x equals negative 8, right? You leave that space for the c term that we're going to create. Now, is my a term 1 here? No, so I'm going to have to factor out a 3. It's not going to be nice, but we can still factor it out, right?
Do you have to do that?
Yeah, there's no other way. So, something that we're used to with factoring is we don't typically factor something out unless it's actually going to factor out. Usually we'd only factor out the 3 if this was like a 9, right? But you can, in reality, factor anything out of any equation that you want. All factoring is dividing each term by whatever you're factoring out. It's just sometimes you're going to end up with a fraction. So I'm going to factor out of 3, which means I'm dividing each term by 3. Now if I divide 10 by 3, as we know 10 is not divisible by 3, so it's just going to be 10 thirds x, okay, which is gross, but it is what it is. So we leave it there. And now from here we're going to go through and do all of the steps of completing the square that we learned about. So we take half of this and we square it. Now that's going to probably require us to do some math because it's not going to be a nice one. So let's say that I'm going to take half of the this term. So I divide 10 thirds by 2 and then square it. Anybody know how you divide a fraction by a number easily? So when you divide a fraction by a number, you're just going to multiply whatever you're dividing by the denominator. So that's going to become 10 sixths squared. What? We can, you're right. Yep. What does that simplify to?
5 thirds.
5 thirds. So that 5 thirds is going to be critical for the next step that we're going to do. And then we have to square this, and that becomes what? What's 5 squared?
25.
What's 3 squared?
9.
So that's how I got that. Now from here, you're going to factor whatever's in the parentheses into 2.
Wait, hold on, I have a question real quick.
Sure.
So for the 10 thirds divided by 2,
Yes.
how would you get 6 or
10 sixths?
mm-hmm.
So there's a trick. If you divide a fraction by a number, you basically multiply whatever you're dividing it by the denominator, which is just a variation of keep, change, flip. You guys remember keep, change, flip, which is 10 thirds. When you divide 10 thirds by 2 over 1, you change the second fraction by taking the reciprocal of it and change to multiplication, which is just going to become 10 sixths. So it's just a simplified version of keep, change, flip. Does that make sense?
Yeah.
Okay. So from here, we now are going to factor this trinomial into 2 identical binomials. So that is always going to be whatever half of 10 thirds is, which we found to be what?
25.
No, you're right, 5 thirds. It's always whatever the part before you square it. Okay. Now, oh, we forgot something. We added a 25 ninths to this side of the equation, so I'm going to have to do that on the other side, right? But we didn't actually add 25 ninths. We added 3 times 25 ninths. What's 3 times 25?
75.
75 ninths. We added 75 ninths to the other side. So I'm going to have to simplify 75 ninths. I can divide the numerator and denominator by 3, right? And this simplifies to 25 thirds. So we actually added a 25 thirds to the other side. So I'm going to just make it more simple looking and erase that the 75 ninths part because it looks too complicated. So we have 25 thirds plus negative 8. How would I add negative 8 and 25 thirds? I have to find a common. Our common denominator here is 3. So I can multiply negative 8, the numerator and denominator, by 3, and I get negative 24 thirds. Isn't that equivalent to 8, negative 8?
Yes.
So negative 24 thirds plus 25 thirds. That equals 1/3. So this is going to become 3 times x plus 5 thirds squared, because I can rewrite it as squared, equals 1/3. Yeah, this is like kind of a gross problem.
Where did you get the negative 24 from?
Negative 24 over 3 is equivalent to negative 8. So I just found an equivalent fraction that would have the same denominator as 25 thirds to be able to add them together. It's just finding a common denominator to add fractions. So now from here, we're at the critical point, right? So this is where we can find vertex form and we can find our solutions. So vertex form is always y equals 3 times x plus 5/3 squared minus 1/3. So we just subtract or add that number to the other side. And then to find solutions, it's a little bit more of a lengthy process. So to find my solutions, I'm going to rewrite my equation at this critical point here. We're going to do an easier one at the end, I promise. And now we're just going to get the squared binomial by itself. So how can I get the 3 to the other side? Divide by 3. 1/3 divided by 3 is 1/9. And then I square root both sides. That gives me x plus 5/3 is equal to 1/3, because the square root of 1/9 is 1/3, but I have plus or minus, so that's going to become x plus 5/3 equals 1/3, and x plus 5/3 equals negative 1/3. Then we are going to subtract 5/3 on both sides. That gives me x equals negative 4/3. And if I subtract 5/3 on this side, that gives me x equals negative 6/3, which is equal to negative 2. So that would be our two solutions. It's a lot, yeah.
Are they always going to be this long?
No. Definitely not.
Which makes it hard.
Even though it's reality, it's just hard because you can lose your place in the problem when you gotta go deal with a fraction. So, yeah. So that's your answer. Does anybody have any questions on this before we move on? There's all the work. Alright, we get to move on, or you guys need a second? Alright, you ready to try an easier one? Alright. Let's try example 6, which is going to be a lot easier. So, example 6, first thing we have to do here is we have to get our c term out of the way, right? So, I'm going to subtract 11 on both sides. That's going to become x squared plus 4x is equal to negative 11. Now in this case, do we have to factor out the a term? No, we can skip that step. It's easier. We don't have to factor anything out. So what's half of 4?
2.
What's 2 squared?
4.
We added a 4 to one side. We have to add a 4 to the
The other.
other side. So this
Wait, how did you get 4 in?
half of your b term squared.
Okay.
Okay. This factors into x plus 2 times x plus 2 is equal to negative 7. I can rewrite x plus 2 as x plus 2 squared equals negative 7. And then this is your critical point, which where you get the vertex form. And the vertex form here is going to be y equals x plus 2 squared plus 7. And then to get our solutions, we take the what of both sides?
The square root.
Square root. This becomes x plus 2 is equal to plus or minus. What is the square root of negative 7? Sorry, I'm writing sideways. My inner right turned around. Plus or minus 7. Square root of 7 doesn't simplify, does it?
I
But-
think it's just the same.
It just stays the square root of 7, but it's not a regular 7. It's a
7i.
Yeah, it's going to be square root of, it's going to be I square root 7, because you have to take out that negative. So basically the easiest way I can tell you this, anytime you take the square root of a negative number, you need to make the product put an I on the outside of it. Okay, put an I on the outside of it.
Always for every negative.
Anytime you take a negative of a square root, it's always going to have an I.
Okay.
Now from here, you have two solutions. X plus 2 equals I square root 7. And x plus 2 equals negative I square root 7. The other ones didn't have any negative square roots. So then from here, we would subtract 2 on both sides, and we get x equals negative 2 plus I square root 7. And over here we would get x equals negative 2 minus square root I square root 7. And these would be your two solutions. So, you know how earlier I showed you how you could use the alternative way to solve the problems? You know how I showed you the vertex form and all of that stuff? And how you could do it the other way? This problem, you can't do the other way. Okay, that's why using completing the square is so important. Because when you have an imaginary solution like this, you can't use normal methods. You have to do completing the square. It's the only way, other than quadratic formula, which we'll eventually talk about. But yeah. Any questions on that? Okay. So from here, because this is such a complicated process, what I would like you to do right now before you try your homework is to try these two U-try problems. I'm going to do them on the board, and then you can check your work with me. So I'm not going to go through the steps. You guys do it on your own, and then I'll put up the answers to check and see if you've done it correctly. Okay? So go ahead and try these two problems on your own. Yes? You mean for the first one? So for the first one, there is no C term, so they already moved it to the other side for you. So yeah, then you're just going to factor out the 3 on the left side. I can get the first step started if you want. So here's the answers to example 6 and the 2 U-try questions.